Hello and welcome to I Know Dino. I'm Garrett.
And I'm Sabrina.
And today in our 438th episode, we have a bunch of news, and I don't know anything about it because Sabrina's doing all of it. So what are you going to tell me about?
Well, we've got some papers on what early dinosaurs were eating, and there's a lot of new exciting fossils that have been found recently. And we've also got a short dinosaur sci-fi film. It came out a while ago, but it's worth watching.
Cool. I also have a dinosaur connection challenge, which I think went in a really interesting direction. It's about a famous mathematician named Emmy Nerta, but my connection doesn't have anything to do with math, which is fun.
Oh, no.
And of course, we have our dinosaur of the day, Mymoorapelta.
You should like that one. It's an ankylosaur.
Yeah, I didn't have to look up how to say that one. I knew that one immediately. But before we get into all of that, we want to thank some of our patrons for helping to keep our podcast running. And we have 2 new patrons to thank this week, getting their first shout outs. And they are Brenton and Clarissa, as well as John. Thank you both very much for joining. And then rounding out our shout outs, we've got Melina Manoli, Dr. Vespa, Histologysaurus, the Gray Allosaurus, Dragon Feathers, Brooke, Rocco Raptor, and Krista.
Thank you so much for being part of our community. We really appreciate you all. Jumping into the news, the earliest dinosaurs had surprising diets.
Was it other animals?
It's more about how dinosaurs had all different ways of eating foods, but what did they eat? And how did the first herbivorous dinosaurs become herbivorous plant eaters? This was published in Science Advances. It's open access, so if you want to read it later, we'll have a link in our show notes. And it was published by Antonio Balel, Michael Benton, and Emily Rayfield. And it's all about the skulls and the teeth, partly because there's not enough gut contents, unfortunately, or coprolites to study.
But there are a ton of teeth.
And lots of skulls. So with curved serrated teeth, we usually consider those types of teeth to mean that dinosaur was a carnivore. Makes sense, you're ripping apart the flesh. Ornithischians had more triangular teeth, and then sauropodomorphs had finely notched teeth. And because of this, we have hypothesized that dinosaurs started as carnivores, and sauropodomorphs and ornithischians evolved independently to be herbivores.
Mm-hmm.
But more recent discoveries show that some dinosaurs had teeth that were in between the types of teeth for carnivores and herbivores. And plus, we've got silosaurids to consider. Did ornithischians come from silosaurids? That's a big question going around.
It is.
So for this study, the authors looked at 11 early dinosaurs, including ornithischians, sauropodomorphs, and early saurischians/theropods. And specifically, they looked at Herrerasaurus, Eodromeus, Buriolestes, Eoraptor, Manidens, Plateosaurus, Massospondylus, Nguervu, Thecodontosaurus, Lesothosaurus, and Saturnalia. They compared these dinosaurs to 47 living animals, squamates and crocodilians like lizards, skinks, geckos, snakes, and crocodiles. And then they CT scanned the skulls and created 3D models of the teeth to compare them. And they used machine learning to predict dinosaur diets based on their teeth. They found that there was a wide variety in teeth and how they were used, and the bite force and the stress on the teeth. So sauropodomorphs seem to have started as carnivores and then became omnivores and then herbivores. Ornithischians, quote, might have exploited omnivorous diets. And it seems that dinosaurs started diversifying what they ate during the late Triassic and early Jurassic, and that was a key factor in dinosaurs becoming so successful. And being herbivorous only, or strict herbivory, didn't seem to evolve until later for sauropodomorphs and ornithischians.
Oh, really? So even in the early Jurassic, they weren't strict herbivores. That's very surprising.
Yes. It's kind of a mix and match, these dinosaurs that the authors studied and what happened, but it kind of shows that dinosaurs were just doing what they needed to survive and thrive. So dinosaurs with curved teeth, that's Herrerasaurus, Eodromeus, Buriolestes, Eoraptor, Manidens, they had these large areas of high stress. And Lesothosaurus and Saturnalia had large areas of low stress.
That's on the models of the teeth?
Yes. And this helps inform our hypotheses on what they ate. The authors found that Herrerasaurus eodromeus, which are both early saurischians/theropods, and Buriolestes and Eoraptor, which are early sauropodomorphs, were carnivores.
Okay, so that's not surprising, because we always say all the early dinosaurs were carnivores, whether they were things that were on the ancestral family tree of sauropods or other herbivores or later meat eaters. They all started out as meat eaters.
Yes, but this is only 4 out of the 11 early dinosaurs that they studied
Okay.
that they found to be carnivores. And these dinosaurs all had, quote, curved blade-like teeth with fine serrations, end quote. So, like you were saying, I think to be expected. They found Thegodontosaurus, Plateosaurus, Massospondylus, and Niguervu to be herbivores, and those are all sauropodomorphs.
Okay, so those are all significantly later, because those are latest Triassic to early Jurassic. And by that point, they've evolved some herbivory, even though the earliest ones were carnivores.
Yes, and they all have similar teeth that, quote, favor omnivory or herbivory. They found that Plateosaurus had some similarities with omnivores, so it may have occasionally eaten meat.
Oh, that's a fun detail.
Yeah.
I always think of Plateosaurus as an herbivore.
Me too.
Which was kind of weird, because Plateosaurus comes up pretty early in terms of the sauropodomorphs. Like, I think it goes all the way back to like 215 million years, which is sort of a halfway point between the first dinosaurs and the Triassic-Jurassic boundary. So it being so big and maybe a pure herbivore was always like, wow, look at that. They were really going by that point. But if it was actually an omnivore, that sort of changes how we think about it.
Definitely. And the authors found Lasutosaurus, which is an ornithischian, to be either an omnivore or herbivore. They're thinking it probably ate soft plants and then occasionally was an omnivore. Manidens, which is a heterodontosaurid ornithischian, they found to be either a carnivore or herbivore. And Saturnalia, a sauropodomorph, was either an omnivore or carnivore.
So out of all of those, even the ones that were late Triassic, early Jurassic, there weren't any obvious straight up herbivores, which is what you were saying. That must have come later.
Yeah. They did caution interpreting what a dinosaur ate, because in some cases, the dinosaurs had unique teeth, like manidens had, quote, denticulated hand-shaped teeth.
Yeah, we've never talked about hand-shaped teeth.
No.
So is leaf-shaped teeth.
Yes. Or spatulate, or, pencil-shaped. So they also said finding manidens to be a carnivore was unexpected and, quote, likely the result of analyzing isolated teeth in a species that had evolved a dental battery composed of closely packed, high-crowned teeth as an adaptation to herbivory.
Oh, that's a good point. Yeah. Because that's sort of like, are you looking at an individual tooth? Are you looking at just the jaw? Are you looking at all the teeth and the jaw all combined as it was when it was alive? You can get different answers depending on what you look at.
Yeah. And so I guess for this study, it's more looking at the individual teeth, but maybe future studies, you expand on that.
Okay. So maybe it's possible that in the future, someone might look at Plateosaurus and be like, well, when you add in some other factors, it is an herbivore. Or the same for some of the other ones, like you were saying with manidens. I don't know anything about manidens. I don't think I'd ever even heard of that one until you just mentioned it. That's cool. It's always good to figure out more about what these early dinosaurs were doing, because it's hard to figure out that Triassic stuff.
And they affected what the later dinosaurs were doing. So, yes, we've talked now about the diets of some of the earliest dinosaurs, and some of them were surprisingly carnivores or omnivores, but how did those dinosaurs evolve to only eat plants? And this next study, they were specifically looking at Ornithischians. And the reason it's interesting is because most dinosaurs were plant eaters, even if they started off as a group being carnivores. This was published in Current Biology by David Button and others, and it's also open access. And in this study, the authors looked at 5 dinosaur skulls: Heterodontosaurus, Lasutosaurus, Scelidosaurus, Hypsilophodon, and Psittacosaurus. So I think we've only got one overlapping dinosaur here, Lasutosaurus.
Oh, yeah. Yeah, there was a Heterodontosaurid, but it wasn't the OG Heterodontosaurus.
So these are some of the earliest Ornithischians, and they represent 5 of the major groups, which include Heterodontosaurs, Thyreophora, that's the group that includes Stegosaurus and Ankylosaurus, and Ceratopsia, which of course includes Triceratops. to give you an idea of what these dinosaurs kind of looked like, the authors CT scanned the skulls and they made 3D models and they reconstructed the jaw muscles and then compared them to birds and crocodiles to figure out where the muscles were. And then they analyzed the bite force based on the skull muscles, and they found that all the dinosaurs had different ways of eating plants.
Huh. I guess it makes sense. We're always talking about, in order for all these different dinosaurs to coexist, they had to have different niches, maybe either eating different food or eating different levels of food or different ages of the plants.
Yeah.
Got to find something different.
Well, it's not just a matter of a lot of dinosaurs eventually evolved to eat plants. They evolved in so many different ways, and they eat different plants and different styles, everything.
I feel like all of us today, when we think of a plant eater, think of cows grazing and goats grazing and all these grazers that are just eating grass. And sometimes even when you see paleo art from people that don't know about the botany of the Mesozoic, that's what they draw, right? It's like all of these dinosaurs eating grass, basically. But we know grass hadn't even evolved, especially in the early Mesozoic. And barely at the end of the Mesozoic.
So some dinosaurs may have eaten grass, but the majority didn't.
Yeah, and they were eating all sorts of different stuff like horsetails and cycads and who knows what.
Yeah, so then the question is, how did these dinosaurs start experimenting with different ways of eating plants? Now, they found that Lasutosaurus had the lowest bite force, and they found it to be an omnivore, which is pretty consistent with the other study we just talked about. Then Heterodontosaurus had large jaw muscles compared to its skull size and had a strong bite force, which is good for eating tough plants. And Heterodontosaurs, they have the two large canine teeth that stick out, so.
Sort of like a saber-toothed cat, but smaller.
And they're going after plants.
Yeah.
Now, Hypsilophodon had a low bite force, but its muscles were placed in a way that they're more efficient, which is, quote, consistent with an emphasis on extensive oral processing between the cheek teeth, end quote. In other words, they're good at chewing. Scelidosaurus was large, and being large helped it with its bite force, but it had smaller jaw muscles, and it processed a lot of food in its gut.
Oh, interesting. Yeah, we often talk about dinosaurs didn't necessarily have to chew because they could use a gizzard to grind up the food, but some dinosaurs, it seems like, did chew.
And then Psittacosaurus had a robust jaw and an efficient skull, so it had a strong bite force, which was also good for eating tough plants.
Yeah, I assume Psittacosaurus would have the strong bite force.
Yeah.
It also has the beak to go with it, to add another level of intensity.
Yeah, so to sum up, thyreophorans were big, and that helped them eat. Heterodontosaurs had large jaw muscles, and that's what helped them. Ornithopods had efficient jaws, and ceratopsians had a combination of features to help them eat. And also the authors point out that Ornithischians having multiple solutions to becoming herbivorous just shows how unpredictable evolution is.
Yeah, that's a good point, because it's always tempting when you're looking at an ecosystem to say something like, well, this animal wanted to eat that, so it evolved this. But that's not how evolution happens. It's much more random. And it could be that they were all evolving to eat the same type of stuff, but they were doing it in different ways. And then just as a side effect of that, they ended up fitting in these different spots. And they were like, this one evolved a stronger bite force. It was trying to eat the same sort of plants, but since it was a stronger bite force and it could handle tougher stuff, it ends up focusing on that more and evolving in that direction. Whereas one that had the ability to chew more might end up going in a different direction for these types of plants that could benefit from being chewed in the mouth more effectively, or wouldn't get ground up in the gizzard as well as they are if they're getting chewed in a mouth, or who knows.
Yeah, it's hard to say.
And then you add 10, 100 million years of evolution and you end up with all the craziness that we see later on in the dinosaur family trees.
Yep, spike tails, frills, all kinds of stuff.
Huge beaks, little tiny heads, crazy long necks.
But they're all Ornithischians.
Yep. Except for I named crazy long necks, which would be a Saurischian, but that wasn't really in this group.
Oh, yeah.
Going off on a different tangent.
I was thinking of the study.
Yes.
Well, speaking of frills and Ornithischians, there's a new Torosaurus specimen that's been found, so that Torosaurus debate will probably continue.
I think that every time I see Torosaurus in the title of anything, like, oh, I guess they're on Team Torosaurus, not Team, it's just a really big Triceratops.
Yes. So these fossils, they were first found in 2021. Amanda Cantrell was working with a landowner in New Mexico who said, quote, "I have a bone in the ground." This is according to the article in Santa Fe, New Mexican. And it was an upper arm bone. As the team dug, they ended up finding about 50 to 60% of the body, including a skull, though the tail's missing as well as the horns on the skull. But it's pretty good.
Yeah, 50 to 60% of the body is really good, especially for a ceratopsian, because a lot of times we talk about with ceratopsians, they just find the skull. Because I guess the rest of the animal is pretty tasty, and the skull is really hard to eat, just being a huge block of bone. So that's really cool.
Yeah, it is. In this case, the skull weighs about 1,000 pounds, or about 450 kilograms. They think it's Torosaurus lattice for now. Oh, and the skull's about 10 feet or 3 meters long.
Yeah, all the Torosaurus skulls are freaking huge.
Torosaurus / adult Triceratops,
Yep.
depending who you ask.
I like describing their skulls as like the size of a small car.
Yeah, me too. So this specimen was excavated by a team that works on private land and sells specimens. But the plan is for the skeleton to go on display in the Museum of Evolution in Denmark this summer. The skull's already on display there, and the museum bought that specimen.
Cool.
And within 10 years, it'll come back to the US, and then the plan's to donate a cast to a New Mexico museum as well. And the Denmark Museum will allow scientists to study it, so that's why I'm saying maybe there will be more to the Torosaurus Triceratops debate soon.
For sure. I think it'd be really helpful with that debate if they expanded beyond just the skull and looking at the unique features of the animals. And in this case, having 50 to 60% of a Torosaurus, and we have some more complete Triceratops, we could start comparing some of those body parts, because traditionally we basically just look at the skull.
Yeah, but like with ankylosaurs, how you look at the skull to determine if it's a new genera or species, I wonder if the same applies to ceratopsians.
Yeah, but I mean, with ankylosaurs, sometimes they branch out. It just depends. And we're going to continue on with our new dinosaur discoveries with a new spinosaurid in just a moment. But first, we're going to pause for a quick sponsor break.
We've got another exciting discovery. This one's a new spinosaurid that is very complete, and it was found in La Rioja, Spain.
Nice.
This is just the first. This dinosaur has been discovered. There's no scientific papers on it yet.
Yeah, there's that timeline of dinosaur discoveries that we always follow through the media cycle. So this is the very first, hey, we found something in the ground. And then you get the, hey, we got it out of the ground. It's going to a lab. Hey, maybe it's a new species. And then we get the scientific publication maybe like 5 years from now.
Maybe less. Maybe sooner.
It can be, yeah.
So these fossils were excavated in July of 2022. They're still excavating. Parts of the skull have been found, as well as vertebrae, ribs, a virtually complete arm or forelimb with claws, and parts of the leg. And they're estimating it's about 23 to 26 feet or 7 to 8 meters long and weighed about 2,800 to 3,300 pounds or 1,300 to 1,500 kilograms. And they're saying they're going to name a new species soon based on this find.
Cool. Yeah. That's another one where it's mostly named based on skulls. So it's good that they got parts of the skull, at least. I'm excited about that arm.
Yeah.
We don't find a lot of Spinosaur arms. That's super cool.
And then another exciting discovery is the Natural History Museum in London recently figured out that an agate crystal in its collections is a titanosaur egg.
What?
Yeah. This has been part of the mineralogy collection since 1883, and it was collected in central India by Charles Fraser, who lived there between 1817 and 1843. So he collected this before we knew about dinosaur eggs, and possibly before we even had the term Dinosauria.
Yeah, seriously, probably, because that was named like barely before he left.
Yeah. The egg is spherical, and it's light pink and white banded inside. It's about 6 inches or 15 centimeters across.
Certainly sounds titanosaur egg.
Yeah.
Round 6 inches across.
Well, Robin Hansen, who's one of the mineral curators, helped prepare it to go on display in 2018. And then a few months later, visited a mineral show in France where a dealer showed her an agate dinosaur egg that looked just like the one she just helped prepare.
Oh, wow.
Yeah, so she kind of recognized it.
It's a happy coincidence.
It is. So Paul Barrett and Susanna Maidment studied it, and there's this thin layer around it that looked like a shell, and then it looked like 2 other eggs were next to it once upon a time. They tried to CT scan the egg, but it was too dense to see any details. This egg's about 67 million years old, and based on the size and shape and surface of the eggshell, and based on where it was found, it's most likely a titanosaur egg. It's possible that there was a nearby volcano that erupted and then debris and lava covered the egg and the rest of the nest, and then silica-rich water got into the shell and crystallized.
Oh, yeah. Yeah, because agate is a lot of silica. That makes sense that they would say it was a volcano, too, because that's how you get a lot of silica.
Yeah. So the egg's on display as part of the exhibition Titanosaur Life as the Biggest Dinosaur.
Oh, that's the one that has the Patagotitan replica in it.
Yeah.
I just saw some pictures posted of that. It looks really cool.
They got a few cool things on display there.
Right? They weren't expecting that when they were planning the exhibit. They're like, wait a second, we've got this thing that's 150 years old. Found 150 years ago. That's really cool.
Yeah, it's a fun story.
It reminds me of the opalized fossils in Lightning Ridge in Australia, where it's like it is a dinosaur fossil, but it is one of the most different than, it's gone through really significant changes. So there isn't a ton you can find from the original material. You're not going to find like soft tissue or anything with this, but it's still really cool.
Yeah.
I'd like to learn more about agatized dinosaur eggs at some point.
Yeah, it's right up there with opalized fossils for me.
Yeah. And apparently they must be semi-common if this one person has stumbled onto two of them.
I suppose. Now, also in the UK, the Crystal Palace Dinosaurs recently got more funding.
Hey, they've been working on that for as long as we've been doing this podcast, and probably way longer.
Yeah, I think way longer. The funding comes from the UK's National Lottery Heritage Fund, which has over £24 million for total funding, and then part of that is going to go to Crystal Palace Park. I'm not sure how much. But we know that Crystal Palace dinosaurs need a lot of maintenance, so that's good.
Yeah. Yeah, I think they had the one that they had repaired. I think the Megalosaurus was the one that they repaired, and that ended up getting broken during COVID. Probably somebody climbing on it broke off the jaw. But the rest of them really need to get repaired soon, and the longer you wait, the more damage they get. So it's great that they can get to it now.
Definitely. All right, a last piece of news. I promised the short sci-fi film. It was made by Danny Donahue. It's called Hell Creek. And I want to thank one of our listeners who shared this with us. They described it as an edge-of-the-seat film, and it didn't disappoint. It's called Hell Creek, like I said, and it's a pretty cool concept. The short synopsis is, quote, a time traveler is hunted by a dinosaur, ...
There's several movies that could be described with that brief ellipsis.
With the time traveler?
Yeah, we've seen time travelers. Any movie where you time travel to the Mesozoic, what ends up happening is you get hunted by a dinosaur.
Yeah. So this film, it's under 6 minutes, and the filmmaker, who also stars in the film, did all the dinosaur VFX work on his own.
Wow.
Yeah. He said in the comments of the film, it's, quote, kind of a short Jurassic era prequel to a longer story that takes place in Hell Creek, hence the title.
Not Jurassic era, Cretaceous era.
So I made that same mistake until I dove a little bit deeper. So I'm pretty sure it's an Allosaurus that's chasing the time traveler.
Oh, okay. Why isn't he in the Morrison Formation then?
Well, it seems that this started off in the Jurassic with the Allosaurus, who follows the time traveler to the Cretaceous/Hell Creek.
Oh, I see. Interesting.
Because he's got this backpack on, and after so much time, he just gets transported.
Oh, I see.
There's no dialogue in the film, but they pack a lot in, and the CGI is impressive. They've even made sure to include details like getting the hands right. Allosaurus, it's a clapper, not a slapper.
Good.
So I appreciated that. And Danny said that they filmed over 2 days with a 2-person crew, and then he spent months where he learned 3D animation and did all the animating and compositing and mixing and everything.
Jeez.
Yeah.
I would have thought it was somebody who did this, like did animating for a job and was like, I could do this on the side, not I'm going to figure out how to animate and start with a dinosaur project.
Yeah.
That's a lot of work.
Must like dinosaurs.
Seriously.
I hope that there is another film, the longer story that takes place in the Hell Creek. That'd be fun to see.
That would be. All right, now for our Dinosaur Connection Challenge with Amalia Emmy Nerta. And thanks to Juliana for sending us this one. As a quick aside, we have a niece named after Amalia Emmy Nerta.
Mm-hmm.
Our brother-in-law is a mathematician, so that's why that happened. So if you wanted to do a connection to that, you could say there's a girl named after Eminurta who has an aunt and uncle who do a dinosaur podcast, which would be like a 3 degrees of separation situation.
Too easy. Too easy.
It is. It's also kind of a distant connection. But Nerta was an amazingly accomplished mathematician. Einstein and others recognized her as an incredibly brilliant mathematician in her time. And in fact, Einstein wrote a letter to the New York Times when she passed away in 1935. Famously, he said, quote, "Fraulein Nerta was the most significant creative mathematical genius thus far produced since the higher education of women began," end quote. And some have criticized that, saying he was basically saying she was good for a woman. But to me, it sounds more like an endorsement of why women should be encouraged to study math, even at the highest levels of education. And especially because he added, quote, "In the realm of algebra, in which the most gifted mathematicians have been busy for centuries, she discovered methods which have proved of enormous importance," end quote.
I can see how it's interpreted both ways, but I think I agree with you. He's encouraging more women to go into higher education.
Yeah, especially because he said, like, in the time period since the higher education of women began, he's not drawing attention to the fact that she's a woman specifically, but that there are women who are being educated for the first time. And I also think you could interpret it as, like, why did we wait so long? Because at that point, it wasn't a very long time period since people were allowed to educate women in this way.
Think of all those other brilliant women who didn't get a chance.
Exactly, yeah. Some of them found a way by like publishing under a brother or a husband's name or something, but a lot of them just didn't get a chance. So Nerta has a couple of theorems named after her, just to prove that she is a significant mathematical genius.
Just like when you have dinosaurs named after you.
Yeah.
And you're significant in paleontology.
Yeah. Especially if you have several dinosaurs named after you. I'm sure there are a lot of ways to connect her math to dinosaurs, but I felt like that'd be too easy. And it would just be like, I could just come up with some math story, like a dinosaur is walking this fast in this direction and another one's going this way. And also, I think it wouldn't necessarily be that interesting to our non-mathematician listeners. So instead, I'm going a different way with it. So Nerta was born in 1882, which was in the middle of the Bone Wars.
Oh.
It was actually the same year that the very first Edmontosaurus skeleton was collected. At the time, it was identified as Diclonius, aka Trachodon, by Cope. Later, it was considered Anatosaurus and Anatotitan before eventually being synonymized with Edmontosaurus. And it was a really great find. It included a complete skull and most of the skeleton, but even better, originally, it had skin impressions and signs of a beak with the fossil, which is really cool.
Especially skin impressions found in the 1800s.
Yes. I couldn't tell for sure if those are still around. I kind of think they might have been prepared away because everybody that talks about it says like originally it had this, which sort of implies that maybe now it doesn't. But it's a cool year to be born if you're a dinosaur fan, especially if you like big hadrosaurs. More directly, she grew up in Erlangen in Bavaria, Germany. She went to the University of Erlangen, where she received her doctorate, and Eugenius Johann Christoph Esper was a professor at the University of Erlangen about a century before she was born. The reason I bring that up is because he's famous for being the first person to formally research paleopathologies.
Nice.
I'm not sure what animals specifically he was looking at, but he did study and illustrate birds, among many other things, which means it's possible that he studied dinosaurs, and that would mean that Nerta studied math where the very first dinosaur paleopathologies were documented.
That's a roundabout connection.
It is. But I think it's really cool. I'd never heard of Esper before, and the fact that he basically started the formal field of paleopathologies, and the fact that he went to the same university in Germany that Nerta went to, I think is pretty cool.
Yeah.
One last connection. About 50 years before Nerta was born, the remains of Plateosaurus were found just a few miles from Erlangen.
Good. So there was a lot of dinosaur stuff happening around her.
Yep. The time she was born, well before she was born, in the place where she lived. Lots of dinosaur stuff. And in just a moment, we'll get into our dinosaur of the day, Mymoorapelta. But first, we're going to pause for one last sponsor break.
And now onto our dinosaur of the day, Mymoorapelta, which was a request from PaleoMike716 via our Patreon and Discord. So thanks. As I mentioned earlier, it was an ankylosaur, specifically a Nodosaurid, so no club tail, and it lived in the late Jurassic in what is now Colorado and Utah in the US, in the Morrison Formation, where Allosaurus is from. Speaking of that sci-fi film.
So we know partly what it needed its armor for.
Mymoorapelta looked similar to Nodosaurus. It was heavily armored and covered in scutes, and it had spikes coming out of its sides. It walked on all fours. It had a long tail. It was low to the ground, and it had a small, elongated head. It's estimated to grow up to almost 10 feet or 3 meters long.
Oh, it's tiny for an ankylosaur.
Yeah. And to weigh about 660 to 1,230 pounds or 300 to 560 kilograms.
It's so lightweight for an ankylosaur.
Yes, it's one of the smallest known ankylosaurs, and it's the smallest known four-legged dinosaur from the Morrison Formation.
That's a good point, yeah, because usually the four-legged things are big and heavy, not under 10 feet.
The skull hasn't been described in detail, but it looked similar to Gargoylosaurus, which is also from the Morrison Formation. And Gargoylosaurus was named in 1988. So it had a narrow snout and triangular skull. Mymoorapelta also had 2 large horns on the brow and 2 horns on the cheek, and small leaf-shaped teeth. It had 13 ribs and 4 sacral ribs, which are rib-like structures around the sacrum, which is connected to the pelvis. And it had short limbs, which makes sense. It's low to the ground.
It would be funny if it had really long limbs.
According to Kirkland and Carpenter, who named Mymoorapelta, they said, quote, the proportions of the ulna and ilium in Mymoorapelta suggest it had a stance reminiscent of that observed in stegosaurs with its high, narrow hips and short, powerful forelimbs, or arms. Mymoorapelta had a somewhat flexible tail. It's more flexible than ankylosaurid tails that were strongly fused. Its tail vertebrae were longer than they were wide, and it had spikes on the tail. Its tail may have been used for defense or for fighting other Nodosaurids. It also had large spiky osteoderms on its side and back, and 5 armor types have been found with Mymoorapelta. There are long spines with a hollow base and a long groove up the side, thin triangular plates with a narrow asymmetric hollow base, small blade-like spines with a rounded solid base, isolated flat scutes, and scutes fused into a single sheet of armor.
I like the fused into a sheet of armor strategy.
Yeah. Now, the large spine was probably at the base of the neck and then pointed outward.
Yeah, so like out the shoulders, basically.
The thin triangular plates were probably attached lower down the body and to the tail. Part of the sacral shield was preserved, and that included a small piece of armor that has 1 large osteoderm surrounded by smaller osteoderms, and it looks flower-like. It also had keeled osteoderms, or bosses, and elevated knobs as well on the sacral shield. And its back and tail were covered in small osteoderms in between larger plates of armor. This is based on comparisons to Sauropelta, why we think that.
Cool. So that big shield fused piece was over the sacrum. That kind of makes sense because you don't need as much flexibility where everything's all rigid.
Yeah. Might as well have armor. Mymoorapelta lived in a semi-arid environment with wet and dry seasons, and there were floodplains. And as for what it ate, it had a high relative bite force based on its jaw joint.
That's not something you hear for ankylosaurs very often.
That's true. It was probably a low browser, and it probably was a selective feeder because it had a narrow snout, so it was a little pickier, and probably ate cycads and conifers. The type and only species is Mymoorapelta mazii. It was described by Jim Kirkland and Kenneth Carpenter in 1994. The genus name means Mygat's shield, and it was named in honor of Vanetta Moore and Pete and Marilyn Mygat, who found the Mygat Moore quarry where the fossils were found.
Makes sense.
It does. The species name is in honor of Chris Mays, president of the Dynamation International Corporation and Society, who funded excavating the quarry.
Dynamation?
Yeah.
That sounds like dinosaur animation.
It does. but I didn't look it up, so I don't know.
I kind of doubt that's what it is.
The quarry site was found in March 1981 by Peter, Marilyn Mygat, and John D. and Vanetta Moore, quote, while on an excursion in the high desert of western Colorado, end quote. That's according to Kirkland and Carpenter. I think they were hiking. And then the fossils were first found in 1990. This quarry is, according to Kirkland and Carpenter, quote, interpreted as an attritional accumulation of abundant dinosaur remains at a permanent waterhole, end quote. So it could be that animals were killed there coming down to the waterhole to drink, or animals died of thirst and or starvation at the waterhole during a drought, or they became trapped in the mud along the margin of the waterhole when they're seeking water during dry periods when the waterhole was small. There's a lot of evidence of scavenging or subsequent trampling, so any specific cause of death for any particular animal, we don't know. However, in this quarry, Mymoorapelta is the third most common dinosaur that's been found. For reference, Allosaurus is the most common, and then it goes Apatosaurus.
Sounds a little bit like the Cleveland Lloyd quarry.
A little bit,
with all the Allosaurus.
What's going on with all these Allosaurs? Mymoorapelta was the first known late Jurassic ankylosaur from North America and one of the earliest known Nodosaurids. The holotype includes a left hip bone with bite marks, vertebrae, ribs, limb bones, and lots of osteoderms. It's got a fused vertebral column, so the holotype's considered to be an adult. Kirkland and Carpenter said, quote, although it is obvious the animal was fed upon, it cannot be determined if the animal was killed by a predator or simply scavenged, end quote. That's the case a lot of the times.
Yep, it's hard to know. It's easy to, the only thing you can usually prove is that it wasn't killed by an attack, because you can see some growth over the injuries. But if it's dead and something's chewing on it, you can't tell plus or minus a couple days
Yes.
where that fits in.
Yeah, we've talked about that with ourselves, if we're eating chicken wings, there's no signs of, did I hunt that chicken or did
someone else hunt it?
Yeah.
Yeah.
Now, the bite marks found on Mymoorapelta may be from a very large Allosaurus, an unusually large one, as it was described, or some other large carnivorous dinosaur, because again, it's so hard to tell from a bite mark a specific dinosaur. Over 160 bones of Mymoorapelta have been found, and they were scattered over 27 yards or 25 meters of the 1,600 square foot or 150 square meter quarry. Although it's disarticulated, according to Kirkland and Carpenter, Mymoorapelta is, quote, one of the most complete Jurassic ankylosaurids described to date, and, quote, the smallest adult quadrupedal dinosaur yet identified in the Morrison Formation.
So an important one.
You'd say that about every ankylosaur.
I don't know. They're not all important.
Wow.
One that's really complete is more important than one where we just have a couple of bones and are from a formation with like another ankylosaur or something.
Well, in addition to all those bones, they also found a small dinosaur egg that was less than 4 inches or 10 centimeters in diameter with, quote, unique Ornithischian-style microstructure. So this egg was associated with the ankylosaur.
So maybe it's an ankylosaur egg.
Maybe.
A Mymoorapelta egg, perhaps.
Another thing that's so hard to tell.
Yeah.
But because no other Ornithischians are known from the quarry and none of the Saurischian dinosaurs, other than maybe a small theropod from this area, were small enough to have laid such a small egg, Kirkland and Carpenter wrote, quote, we suspect that egg may have been aborted on the death of the ankylosaur. Although speculative, if the egg belongs to the ankylosaur, it suggests that the death of the animal may have been sudden, perhaps by the animal being trapped in the mud and then killed or at least scavenged.
That's kind of sad.
Yeah.
But on the bright side, now we have that thing fossilized so we can learn about it.
If it was a sudden death, at least it didn't suffer.
There you go.
Bright
There's
side.
a silver lining.
Yeah. Kirkland and others also referred a partial skeleton to Mymoorapelta in 1998 that was found in Cactus Park, Colorado, but the fossil was still being prepared at the time that they referred it. And this partial skeleton included vertebrae, chevrons from under the tail vertebrae, sacrum as part of the pelvis, and a lot of armor, including parts of the sacral shield that covered the top of the pelvis. More bones have been found at the quarry since, including a nearly complete skull and nearly all parts of the body except for the pubis and femur, so a hip bone and a leg bone. The fossils are at the Dinosaur Journey Museum of Western Colorado in Fruita, Colorado. There was another specimen found near Hanksville, Utah, and that included more osteoderms, ribs, a vertebra, and femur. And another Mymoorapelta specimen was found in 2014 in the Hanksville Burpee Quarry, which is, according to Katie Tremaine and others, a, quote, sauropod-dominated bone bed. So there's 8 known specimens of Mymoorapelta, and 4 of them are known in sauropod territory, sauropod localities.
Yeah, you've got an ankylosaur coexisting with an Apatosaurus. Isn't that nice?
That is nice. So other dinosaurs that lived around the same time and place include Apatosaurus and Allosaurus, of course, and Ceratosaurus and possibly Nanosaurus. And other animals that lived around the same time and place include lots of snails and fish.
Snails.
Yeah, we don't bring them up that often. Talk about turtles way more.
Yeah. And our fun fact of the day is that you can visit rivers on Earth that dinosaurs once swam in, fished in, and drank from.
Interesting. And I'm surprised maybe I'm not surprised that those rivers are still around.
Yes. So the reason I phrased it as you can visit rivers and not naming a specific river is that figuring out which rivers those are is very difficult. Because like you said, it's been a long time. It's hard to know. But thanks to Paul M. on the Discord server for pointing out that some rivers are older than dinosaurs. And Tyrant King pointed out that the quote-unquote new river in West Virginia is a contender for the oldest river in North America.
Wow.
Which is pretty funny that it's called the New River.
Yeah.
Which is a little misleading. But the name probably has to do with a translation of something that sounds like new, or it might mean that it was new to a European explorer, or it was newly added to a map at some point. But yes.
It was new to someone at some time.
It was. The New River is often estimated to be between 260 and 320 million years old, which is not too surprising since the continents are billions of years old on one hand.
That's a very young river by that scale.
Yeah. Compared to North America. If North America could talk, it would be like, yeah, all these rivers are new. But of course, it's really difficult to date a river. According to the West Virginia Geological and Economic Survey, there are several clues to the age of the New River, and they give a very wide range of dates. So they range from 3 million years ago to 320 million years ago. On the old end, the New River cuts through rock that is 320 million years old. So therefore, it must be more recent than that. You can't cut through something that didn't exist yet. So we know it's not billions of years old. 320 million is the upper end. However, the mountains and therefore the course of the river changed a lot over those 300 plus million years. By the end of the Mesozoic, for example, even though the Appalachian Mountains formed much earlier, by the end of the Mesozoic, they were basically completely eroded to a flat plain.
Wow.
So the Appalachian Mountains were pretty much completely gone at that point. And this is, about 60 million years ago. After non-avian dinosaurs went extinct in the Cenozoic, the mountains were uplifted again into their current form. So that's when the Appalachian Mountains that we all know today basically took their shape. Some of the rivers through the Appalachian Mountains followed the course of original cuts in the rock, while others cut new paths. Figuring out which rivers originally formed in the Mesozoic is really difficult because it's still cutting through the same rock. If you imagine you've got this 320 million year old rock, it gets lifted up into a mountain, and then it goes back down, and then it comes back up. And then at the very end of that, you look and you see something cut through it. You can tell that it cut through 320 million year old rock, but you can't tell which one of those lifts and fall downs it happened during. On the younger side of the estimate, the 3 million year age estimate is based on how fast the Grand Canyon is thought to have eroded. As a side fun fact, the Grand Canyon age is often debated, with two camps being the quote-unquote old river and the quote-unquote new river proponents. So it's like another new river. Sometimes people say new river to refer to how new the Grand Canyon is. But the rock at the Grand Canyon is between 2 billion years old at the lower levels and 270 million years old at the upper levels. So everyone, again, can agree that the Grand Canyon is younger than 270 million years and obviously 2 billion years. But some think it's as old as 70 million years, which would be old enough for some dinosaurs. But that's probably a little bit too extreme. Most of the estimates that people come up with put the maximum closer to 50 million years ago. And it's also possible that the Grand Canyon formed in segments ranging from 6 to 70 million years ago. Basically, like one piece of it was carved out separately than the other pieces, and then later on they got connected together. A better contender for a dinosaur oasis is the Finke River, aka Larapinta, in central Australia. It's often cited as the oldest river in the world. It's estimated at over 300 million years old, which is long before dinosaurs evolved.
Yes.
Which would mean that if it was there for all of those 300 million years from the present going back, every dinosaur that was there in that part of Australia throughout the entirety of the Mesozoic would have been encountering that river.
Swimming, fishing, and drinking from it.
Yes. Although now that I'm talking about it, the swimming and drinking part is probably true. I'm not sure about the fishing because this river is one of those that sort of came and went.
Oh, I see.
So it was dry a lot of the time. I'm not sure how many fish there really were in it. But occasionally it could have been connected to lakes and stuff. Maybe there were some fish that made their way in it.
Some dinosaurs may have.
Yes. So I was saying it's hard to know the younger end of the spectrum. So you're probably thinking, how can you know it's at least 300 million years old, not at most 300 million years old? And that's because they have a really clever way to date this river. It meanders in a way that a river does in flat plains, but it's not on a flat plain. And the most likely reason for that is it was lifted up basically by a mountain or a plateau after it formed, and then it kept that current course. So you can look at it and see this like zigzaggy meander that doesn't make any sense for where it is now. It's sort of like when you find footprints or like a fossilized ammonite on the very top of a mountain. You don't think the ammonite was actually on the top of a mountain before you figure it was on a seabed. This is the same sort of thing, except with a river. You can tell it was in a basically like a floodplain, and then it got lifted up later. So we can tell from the geology of it that those mountains were done forming by 300 million years ago, and thus the river must be older than 300 million years ago and older than the oldest dinosaurs. This is also true for several other rivers in the area, like the Hale River and the Todd River, but the Finke River seems to get all the glory.
There can only be one river in the spotlight.
Yeah, everyone wants to know what the oldest is, and for some reason that one got picked as the oldest. And yeah, everybody just goes with it. There's a nearby river called the Diamantina River, which is right by some of those very old rivers, but I couldn't find out for sure if that was in the same group of rivers. I think it might not be because it's sort of connected to a lake, so I think it might have formed later. I'm not really sure. If anybody knows, let me know.
Also hard to know if Diamantinosaurus drank from that river.
That's what I was going for, because I was going to pivot this fun fact as I got to this point in the research to Diamantinosaurus might have visited the Diamantina River, but I don't know if that's true. It would be cool. At the very least, Diamantinosaurus could have visited the Finke River and some of the other ones in the area.
How many fun facts do you pack into one fun fact segment?
It meanders like a river, multiple directions. Yeah, unfortunately for figuring out which river you could visit and pretend that you're a dinosaur in this super old river, or, appreciate that sort of permanence of some of the geological features on Earth, dating rivers is a lot more difficult than dating dinosaurs. But if you do want to visit a river that dinosaurs did, you can go to the outback and hope for rain, because these rivers don't usually have much water in them. But if you time it just right, you can, in fact, swim in the same river that a dinosaur once swam in.
Nice. And that wraps up this episode of I Know Dino. Thank you so much for listening. Head over to iknowdino.com if you want to go to the links to our sources for this episode. They'll be on our website. And stay tuned for next week. We will have an interview with Hans Sues, who is very big in the dinosaur world. He's also the curator of vertebrate paleontology at the Smithsonian, and he's named a whole bunch of dinosaurs, and he also has a dinosaur named after him. Thanks again, and until next time.